Hello and welcome to today's lesson, which is on compound interest. So the first thing I'm going to talk about is this first question. I'm going to go straight into these questions now. Hopefully you will have watched the previous video, which is on percentage multipliers, because we do need that for this one here. So the question says Thomas invests 20,000 into an account that pays 3% compound interest per annum. Now, let's just think about what those mean. So now compound interest means that you're getting the percentage and you're getting a percentage increase of 3% every single year. So you're getting 3%, 3%, 3%, 3%. Per annum means per year. Compound means you're getting that extra 3% every single time. So we're getting 3% every single year. Work out how much money Tom will have after his account, in his account after 10 years. So here, it's worth getting this one down in your notes. It's definitely, stuff like this definitely comes up quite often. So we've got 20,000 here. Now, if you've watched the previous video on multipliers, you'll know how to do a multiplier of 3%. So it's going to be, I'm increasing here by 3%, so I'm adding 3%, which is equal to 103%. And that as a multiplier is equal to 103 divided by 100, which is equal to 1.03. Super. So that's my multiplier. Now, if I want to do this over 10 years, so increasing by 3% every single year for 10 years, then what I should do here is I'm going to do 20,000 times by 1.03 times by first year, 1.03 times by 1.03. And it's already taking up too much space. This is already taking too long. So there is a quick way of doing this. If I've got these times together 10 times, the quick way of doing this, anything times together, so like 2 times 2 times 2, you wouldn't write 2 times 2 times 2, you'd write 2 to the power of 3. So with this one here, instead of writing this out 10 times, I'm going to do 20,000 times by 1.03 to the power of 10. And this is the same as writing it out 10 times. And that there is kind of your basics of how to do compound interest. So here we've got 20,000 times by 1.03. Now, if you're not sure where the power button is, it's this x with a little square to the power of 10. And that's equal to, so this is equal to 26,878. So this is pounds, and that is 0.78 points. Whether it's pounds and pence, it's going to be 327 on here, which means it's 3. So that's that first question done. All right, super. So let's have a look now at example 2. So we're going to go straight into how to, we're not going to do any of this time. So we've got Peter invests £1,500 into an account that pays 5% compound interest per annum. So compound interest per annum means it's going to be an increase of 5% every single year. So it's going to be 100% plus the 5%, which is equal to 105%, which is equal to 105 over 100, which is equal to 1.05. So that's my percentage, that's my multiplier. So now if I'm going to do this over 9 years, it's going to be 1,500 times by 1.05. Now, instead of writing this 9 times, I'm going to do to the power of 9, remember. So, £1,500 times by 1.05 to the power of 9 is equal to 2,326 times by 0.99. 2,326.99. Brilliant. Super. So, that's when we're doing compound interest. Now, we do have a look at these two questions in here as well. So, Alex's car depreciates in value by 18% per year. Now, this one's a little bit different because we're not doing an increase this year. We're not increasing our value. We're depreciating, and cars depreciate in value, which means they come down in value. So Alex bought his car for £34,000. Work out how much the car will be worth after 5 years. So this one here is example 3. So depreciates means we're going down now instead of going up. So my first point is to do my original value, which is 100%, minus the 18% here, which is equal to 100 take away 18 is equal to 82%. To write that as a multiplier, I divide by 100, which is equal to 0.82. So this here is my multiplier for a reduction in 18% each year. So if I want to reduce it by 5 years, it's going to be 34,000, like so, times by 0.82. Now instead of writing this out 5 times, I'm going to do it to the power of 5. Okay, so 34,000 times by 0.82 to the power of 5 is equal to, this time it's 12,605.15. Super. Now I've actually rounded that. Remember to round it if it's money. Okay, so I'm going to pause now. I want you to have a little go at this one here on the right. So you have a little go at that one. I think you should be able to do that now. So let's have a quick go through it then. Make sure you've got it right. So here we've got example 4. So the car depreciates in value by 16% per year. So it's going to be 100% subtract 16%. 100 take away 16 is equal to 84%. As a multiplier, that's going to be equal to 0.84. So this is what I need to multiply by to get a reduction in 16% for every year. So it's going to be 28,000 times by 0.84. Now because we want it over 8 years, it's going to be to the power of 8. Okay, so it's going to be 28,000 times by 0.84 to the power of 8. Brilliant. So that one there is equal to 6,940.52 for that one. Super. All right. So we've looked at increasing. We've looked at depreciation. So we're now going to have a look at one of these questions. So this one here is a little bit tricky. Not that much trickier, but notice that it's 3 marks, which means this has come up in a past paper. It is in the higher paper, this one. So Becky buys a new car for £25,000. The value of this car will depreciate by 20% at the end of the first year, and then by 12% every year after that first year. Work out the value of the car after 3 years. So the way we do this is I'm going to do, this one here is example 5. I think we should be alright with this for now, but I thought it worth doing because these questions do come up quite a lot. So let's think about the first year here. Let's do it over here. My first year is equal to, well, it's depreciating by 20%, so 100% minus 20%, which is equal to 80%. And as a multiplier, that's equal to 0.8. So that's what I need to multiply by to get a reduction in 20% after my first year. So for the next years, I'm going to write here next years. It's a reduction in 12%. So it's going to be 100 minus 12%, which is equal to 88%. And as a multiplier, that's equal to 0.88. Super. So it's going to be £25,000 times by my first year, which is a reduction in 20%, which is this one here, times by, now, because it wants it after the end of 3 years, I'm going to be timesing by 0.88, which is a reduction of 12% here. This is my multiplier for a reduction of 12%. But it's after the third year, so I need to do this to the power of 2, because I've got my first year and then 2 years to make 3. So that one there is to the power of 2. Okay, so I can put that straight into my calculator. 25,000 times by 0.8 times by 0.88 to the power of 2. And then we can do that all in one. So that's equal to 15,488 pounds. Super. Let's just check that. Brilliant. Okay. Notice that they have used these methods. If you see that, times by 0.88, times by 0.8, and you get marks for seeing these here. Okay. So that's why it's important to use the multiply method. So let's have a go at this one here now. Now, this one here can be a bit tricky. All right. Now, the thing is with this one, the best way to do this is to basically use trial and error. You're basically seeing how many times it's going to change. So this one here is example 6. Again, I see these come up all the time at the moment. So Helena, make it big for you so you can get it down. Helena invests a sum of money into an account which pays 6% compound interest per annum. Work out after how many years Helena will have trebled her invest. Give your answer as a whole number for years. So, first thing we need to think about is, what does it mean by trebling trebling her investment? Well, we know that my original amount as an investment is equal to 100%. That's what we know. We know that's our starting point. This is our original amount. So if I want to treble that, I want to see what this is when it goes over 300%. Okay, so times in by 3. So trebling that is going to be 300%. That's what I'm looking for here. Okay, so the next thing I need to do is to think about the multiply method and how many times I need to multiply this by. So if I'm doing an increase of 6%, that's going to be 100% plus 6%, which is equal to the 106%. 106%. As a multiplier, that's going to be equal to 1.06. So this here is what I'm multiplying by to get an increase of 6% every year. So this is an increase of 6% every year. So the next thing I need to do is to figure out how many times I need to multiply this by to get it over 300%, because that's going to treble my investment. So what I do is I start with 100 in here, like so. Okay? And then I'm going to times by 0.16 and press equal. So after the first year, it's going to be 106%. Okay? So that's after 1 year. And then I'm going to times by 1.06 again. So I press it, that's going to give me my second year, okay, which is 12.36. Now what you've got to do is you've got to keep doing this on the calculator until you get over 300. So I'm going to show you this. So that's my second one. So notice it now, it says answer times by 1.06, okay. So to get my third year, I'm going to press it again. So that's my third year. And then you're just going to keep doing this and counting them until you get over 300. So the third year, fourth year, fifth year, sixth year, seventh year, eighth year, 9, 10, 11, 12, 12, 13, 14, 15, 16, 17, 18, 19, 302. So I press that 19 times, which means that to triple your investment, it's going to take, so let's just make it really clear to the examiner, 100% times by 1.06, the power of 19 is equal to 302.55%. Okay, so this is the first time it's going to go over this. We can check that if we want, so we can check this. So 100 times by 1.06 to the power of 19 is equal to the 302. So that means, how many years does it take? It takes 19 years. And we've got to use the multiplier method to find this out, okay? Brilliant. So that's that question. Now these do come up actually, 19 years, there we go. So we've got one more question, and this is the trickiest question on here today. This one is quite tricky. It's about what questions now do we have where they're tricky? It's all about, instead of just putting into an equation and working it out, what we're doing is we're putting in and working backwards, and that's what we're doing with this question here. So the number of fish in a lake decreases by a percentage each year. Given that the number of fish halves in 8 years, work out the value of x. Give your answer to correct to one decimal place. So what we've got here, so let's write this one down as example 7. Example 7. So, first of all, we need to think about the way this works. So, we know that it's given that the number of fish halves in 8 years. That's the important part. It's halving in 8 years. So, what was my percentage before? My percentage would have been 100%, wouldn't it? And if it's halved in 8 years, that means it's now at 50%. Okay? Now, what would I usually do here? Well, usually what I'd do is I'd take my original value, I'd times by the multiplier to the power of the number of years, and it would give me 50%. So, it would be equal to my value here, which is 100%, times by my multiplier. I'm going to call that multiplier. So the power of my number of years, which in this case is equal to 8. And I know that's equal to 50%. Okay? Now this is why it's hard. I'm forming an equation, okay, using the things I've got. So my original amount, which is 100%, times by my multiplier to the power of the number of years is equal to half of the number of fish, so 50%. So what I've got to do now is I've got to work backwards from this, okay? So 50% divided by 100%, so 50 divided by 100 is equal to 0.5. So that's my starting point here. So this here, I'm going to divide both sides by 100%. So that gives me 0.5 is equal to my multiplier to the power of 8, like so. So if I want to work out what my multiplier is, then I need to get rid of this power of 8. So what's the inverse of doing the power of 8? Well, the inverse of the power of 8 is the 8th, the root on the other side. So the inverse of squaring would be square root. The inverse of cubing would be cube root. The inverse of the power of 8 is the 8th root. So to get rid of this, I need to do the 8th root of this. Okay, now this is tricky. You might not have seen this before. So, if you want to find the 8th root on here, it's just above your x with a square like that. So you'll notice you've got a square outside your root and a square inside your root. You can't just go 8 roots like that. That won't work. You've got to do shift here, shift and this one here, which is the square box with the root. And I'm going to do the 8th root of 0.5. 8th root of 0.5, which in this case here is equal to 0.91700. So my multiplier is equal to the 8th root of 0.5, which in this case is equal to 0.91700. Now, I haven't actually finished there because this is just my multiplier, isn't it? This isn't my value. How do I find out what it's been decreased by? So what's my percentage actually being decreased by? Now the way I find that out is by knowing that when I go forward with this, I know that it's going to be you subtract it from 100% and then you divide by 100. So the opposite of this is I need to see what this is to get to 100%. Now 100% as a decimal is equal to 1. So how much has been taken away from 1 to get my reduction? So it's going to be 1 minus 0.91700, because that is how far away it is from 100%. Remember that this is 100% and I've reduced by this, okay? So it's going to be 1 minus 0.91700, which in this case is equal to 0.083. But remember, this is the decimal, but we want it as a percentage. Now, percentage means out of 100, so I need to convert this into a percentage. Now, 0.083 would be 8.3%. So this is what it's been reduced by. Let's just think about that. Let's do it forward so you can see what I mean. So to get my multiplier, remember that this is my multiplier here. Okay, to get my multiplier, I would have to go 100% minus the value I'm decreasing by, which is 8.3%, which would give me 91.7%. And then as a multiplier, this is equal to 0.917. So this here is what I had to decrease by, the 8.3%. So that there, you don't need this extra part, that's just to prove it. But this here is a decrease in 8.3%. Now that one is trickier, okay? But that's why I've done it at the end. It's a past paper question, it does come up, okay? So let's just check that. 8.3%. They will have accepted 8.29. Super. So I've got some questions here for you to have a go at. So pause now and have a go at these. Okay? Have a go at those questions. Okay, I'm going to pop the answers up. So mark these in green. Brilliant, so thank you for watching this video on compound interest. Remember to make sure you're having a go at these questions, because the only way to learn maths is to do it, and have a lovely day.